My name is Golmohammadi. It's my pleasure today being here, um, giving you updates about my program of hydrology and water quality here at ONA. Um, in today's talk, I mostly focus on groundwater modeling. So when we talk about groundwater in Florida, what makes it super important, the first thing is how we depend on groundwater here. So groundwater here is the main source for different purposes. It's the main source of fresh water for industry, for agriculture, and also for drinking. So the Floridan aquifer, it happened to be one of the most ancient and one of the oldest and biggest aquifers around the world and of course in the United States. So proper management of this system is vital then. And also because of the specific geology and climate condition in Florida. So it's this aquifer system is very unique. So this karstic aquifer with the presence of sinkholes, underground caves, and springs everywhere, it makes it very connected, makes itself very connected to surface water. And it's very important to take that into consideration when we do the research, because if there is an issue in groundwater, then the issue will be observed or in surface water. So one thing about Florida's water system is that the surface water system depends on contribution of the groundwater here. These are the maps. These maps are the groundwater depletion and salinity-related contamination in the state of Florida. And if you want to name the most important issues in Florida's groundwater system, we can name based on the Florida Department of Environment and Protection and also the USGS, they reported they are like groundwater depletion, salinity, and nutrient pollution. So when it comes to nutrients, it's nutrient pollution. It has been reported that nitrogen is the most widespread non-point contaminant affecting the groundwater pollution in Florida. So, but when we talk about nutrient pollution, there are questions coming to mind, like what is the source of these nutrient pollution? We all know that the impact of nutrient in the water system. We know that we are aware of eutrophication, we are aware of like having nutrient in the system cause it may cause degraded spring ecology. But the question is, what is the source? Is it and the other question is like how to prevent and control it. By answering the first question, we can know how to actually what to propose. If like additional measures are required, or like if the source is, for example, the urban system, then we can implement the low impact development, or the problem is from, if the problem is from agricultural area, then best management practices can be an alternative solution. So by knowing these things and by knowing that all the issues and questions, now as part of our program, hydrology and water quality program at ONA, we propose actually we focus on groundwater study. So we have designed different phases for groundwater study here, and various techniques we are using to study the groundwater. So instrumentation and data collection is one thing that we are doing. That's the base for many research areas in this, with the nature of environment and water resources. Hydrologic modeling, including numerical and physical models, are the other option, the other phase of the groundwater study that we do here at ONA. These two studies, instrumentation and groundwater modeling, I'm going to cover it here in today's talk. The other two things that we are doing is image processing, remote sensing, and artificial intelligence. We use them as the forecasting tool. These are ongoing research, and hopefully in the next highlight or any other like next opportunity, I'm going to explain about the results of AI work and image processing. The effort of our work has been published or accepted or under revision in high impact factor journals. So, like before I go start the instrumentation and like explaining the results, I would like to acknowledge the hard work of my team. This is like I'm presenting here today, but this is like the work that all of us together we did it. Like my PhD students, Sayed is not here today. He had to travel, but he's online. I see his name. Saba, she's present here. Maybe next time she presents for us. And Rohit, my researcher, and Amartya, I acknowledge that hard work of all of them. So instrumentation and data monitoring, like in order to settle our data monitoring system, we started with collecting data from available sources. Available sources, I mean like all the organizations which share the data with public or by like registration and logging into their system, we can get the data. So in this map, if you look at the blue dots, those are the monitoring wells. Those are the groundwater wells. So by looking at the wells, we can see that despite the general idea that everyone, we have like groundwater well is a very basic data and it's available everywhere. So we will see that even not a very good spatial distribution of the wells are available everywhere. And we see a lot of gaps in some areas of Florida, and we don't have data there. So there are those three red symbols, the cost symbols that you see there, are like the range cattle, the locations of our research center, Range Cattle Research Education Center here at ONA, the Lupa Preserve, and Buck Island Ranch. So between these three centers, like Buck Island Ranch, we already found that they have a long-term data set available, and the data collection is going on. So we decided our groundwater modeling work, the numerical modeling work, to be conducted there. So this is going to be the study area for our numerical model. But between two other sites, Deluca and ONA, we started our instrumentation capability. So at ONA, we have installed 5 or 6 wells along the river. This is like if you follow this follow the line, like which is the road, and we have the bridge next to it. So we have 5 or 6 groundwater wells. We measure the water level, water quality, the general water quality data are measuring the daily, and also we started to measure the sample also the water quality for the purpose of phosphorus and nitrogen. The other thing, in addition to that, the other data that we started to collect, and instrumentation that we have done is like close to Goose Pond Road, we have an experiment site. And in that site, we have completed this instrumentation. We have done it in this summer, and we started to get the data from September. So here we monitor various parameters like water quality, drainage, storage, climate components, with the purpose of like doing the water balance study here, and look at the impact of different pasture management on water quality. And this is some screenshots of the data that we are excited about, and I wanted to share it somehow with you here. In the Lupa Preserve, this is like we installed 8 wells or stations there to measure the water level and water quality. But in the Lupa, when we talk about the Lupa, there is something important to share with you is that the Lupa currently has no surface water management, surface water measurement. I mean, like we don't know, we have no clue how much water leave the property. So that makes it very hard to do the hydrologic. Currently doing hydrologic research in the Lupa is very difficult. So one of the contribution of our instrumentation would be installation of 2 hydrometric stations there in site 6 and 7. So the site 6, we already installed it. But the site 7, we are going to install it in February because of the very wet condition in the Lupa. We've not been able to get to that point. So on site 6, we started to get the data for the flow in September, beginning of September. And this is a plot from our flow meter that I'm sharing here with you. And if you look at the stage, you can see we have captured all the hurricanes, including the Helene hurricane here. So by having these 2 stations set up and getting the data, and of course sharing with other colleagues and groups, research groups, we hope to contribute to hydrology studies for the Lupa Preserve area. So far, what I've presented was an update about, it was all update about instrumentation progress in our program. So we know that we all know that instrumentation is important, and we know how necessary it is, but sometimes it's like very tough, actually. Here I tried to capture all the challenges, some of the challenges actually we experienced during this time, from falling in the stream or going there and missing, like seeing that we don't have our instrument there. We witnessed like the gator there the same day. So, and also about the animals that always they find their way to get inside our instrumentation box or like find their coziness there or data logger. So based on what we said, like we know that like how like instrumentation is useful, how it's time consuming, and it's very also it's very expensive to our budget specifically. So one alternative option is modeling. So here, like at ONA, we have like we have modeling work, modeling study started, like, and I'm going to explain what we have done using a numerical model called ModFlow. And we simulated the existing and future conditions of the groundwater. So, but that's the thing about modeling. It can be very useful and efficient tool, but if the model has been used properly, but like someone, for example, a user with a very strong knowledge about the science and its engineering behind the model can produce a very valid model. But however, like if someone uses the model blindly, then that can be completely useless or not valid. So here we define the main goal for our groundwater modeling work to provide a tool for simulating groundwater systems, evaluating the effectiveness of existing conditions and alternate best management practices to improve the water quality and quantity here in the basin land. some specific objectives were to develop the Marshmallow model as like specifically for one study area, and to propose alternative solutions or scenarios for based on the situation of the farm or ranch that we are studying, and then prioritizing their management practices to enhance water quality. So the other specific objective was about developing some techniques, various modeling techniques actually to forecast or simulate groundwater parameters. Something like artificial intelligence models or machine learning or image processing are the ones that we are going to develop for that purpose. Here, this is the schematic flowchart about the about our groundwater modeling study specifically. Like the data management phase has been completed for us. Like we have like data collection, monitoring, and data analysis. But of course, the monitoring is ongoing thing, and we hope we can continue doing it. So the conceptual model was developed. The numerical model development was completed using Marshmallow model. And the model was calibrated and validated for the area that we are going to talk about it later in a few. So that gives us one evaluation tool, one valid tool to be able to present or to simulate the existing condition in that study area. And then in the next step, we define some scenarios, and then we define some BMP scenarios, and fertilizer, like the scenarios that we considered for our research was mainly based on the fertilizer management and irrigation management. And based on some decision proposals from models, like decision making tools, we decided which pest management practice actually is the first one. So some future research about the that we can actually some future research about like the interaction of surface water and groundwater, flood susceptibility, and groundwater quality, and climate change impact assessment. Those are the future research, the research that we are going to conduct in the future. And AI application is like something that we already started, and we have some results, but since it's not in the scope of today's talk, I'm not gonna present them. So this is the study area that I talked about in previous slides. Buckeye Ranch was selected for our study area here. And as you see, the model, the modeling area that is like consists of two boundaries. The small boundary is called site scale model, and the bigger one is the regional scale model. So the site scale model actually is selected and limited to Buckeye Ranch, which is a 4,200 acres research ranch and located in the Highlands County. The reason that we picked that area was the intense available data there in terms of water quality. But the regional scale model is being developed it's a common way of developing groundwater model, numerical model. And it's usually is because to eliminate the impact of boundary conditions in a small size. So that's why we usually extend it to the natural system. Here, if you see like our modeling area has been extended to all the way to Lake Istokova from the north and to Lake Okeechobee, and the other west and east side of the model is some rivers, I believe, one of them called Fisher Creek, but the other is the canal that we extended our model area to there. So that was the modeling setup. And then the conceptual model was completely, it means that understanding, it's based on like understanding and simplification of the high level representation of the site. it's like here it's about groundwater, so it's like we have simplified the geology and the aquifer system. When we talk about like the geology and aquifer system, it's like as you see, we have like the first area on the top, which is shown in green, that's the superficial aquifer, and that's where we are looking at impacts of nitrates to that area. So the other aquifers are like intermediate aquifer and Floridan aquifer system that which we are not here, like we are not looking at nitrate concentration in those. So in the next step, we developed a numerical model itself. Like the model using different inputs in the model, such as topography, boundary conditions, hydraulic conductivity, initial head, and other hydrogeological information like inflow and outflow data. We have set up our numerical model. And then the model was calibrated and validated. It's been about like, I think 20 something wells we have there in Buck Island Ranch area, but here for the purpose of presentation, just wanted to show you how model is calibrated and validated after all. I'm presenting 6 points. I mean, these are 6 wells observed data and simulated data. So after making sure the model is calibrated and validated, actually we have done like a statistical analysis for that purpose, and the satisfaction on calibration and validation is based on those results as well. We have water quality, groundwater quality model, which is called NC3D model. It's a 3-dimensional transport model. We have used that as an extension to ModFlow. And we have calibrated and validated that model. And here I'm showing the results of nitrate for 2 different wells during the period of 2019 to 2021. After that, after like the next step, after finishing the model calibration and validation and having a valid tool for the certain area that we chose as a study area, now was the time to define the scenarios. We have defined the scenarios based on a series of conversation meetings with the folks in Buck Island Ranch area, and we ended up having 7 scenarios. So scenario 1 was our base scenario, which is like this is something under existing condition they do. They have like during the month March to May, they have fertilization applied, like fertilize pasture. They fertilize the pasture, and the irrigation irrigation system there, which is based on back pumping, is presented in the first map on the top map. So that was our base scenario, and every other scenario, every other changes we did to our scenario to propose alternative solution is being compared to scenario 1. So scenario 2, 3, and 4, which are categorized and as fertilizer management, they were all defined by reduction, a percentage reduction in fertilizer application. For scenario 1, for example, 20%, then 50%, and 100%, which means that there is no fertilization implemented. So just this is the second category is like irrigation management. Then we decided to change irrigation, like to see what would be the impact of irrigation on the whole system. First, we reduced the irrigation amount to 20%, and then the next one, we had like irrigation only for the month of March to May, the same as scenario 1, instead of having irrigation like during the dry season. And scenario 7, I named it as pasture management because during for this scenario, during this month 3 to 5, fertilizer which was applied to existing condition, we somehow we investigated which pastures had the highest impact. So, and then we removed them, and then we checked what happened to the amount of nitrate in the water. So for the first 5, the fertilizer management scenarios, I have each result here, like if we compare them with the base scenario. And the first one is like comparing 20% reduction, as we expect it's not that much reduction in nitrate. The second one is 50%, which is a very good reduction in nitrate. And the second one, when we have no fertilization applied, so of course there is no nitrogen in the system. Excuse me, there is no nitrate in the system. So the next group of scenarios was like the irrigation scenarios. So this is like, first we just did the same thing for 20% reduction in irrigation, and then we compared it with scenario to base scenario. And then the other scenario was like the one that we changed the months of irrigation. And so the irrigation here did not much impact the nitrate in the groundwater. Somehow, that was somehow something that we expected because of the wet condition of the Buff Island Ranch area, and not much irrigation generally applied there. So the third group was the pasture management. Here in these are like the one in dark red, reddish color. Those are the pastures that had the highest impact of like nitrate. And then we stopped fertilization in those pastures to see what would be the impact on groundwater nitrogen system. So we will see that the nitrogen reduced substantially in the groundwater. So after doing this, like it was like we have used a multi-criteria decision-making model, which is called NCDM. All the things these management type model does, they allocate weights to scenarios, to the indices that we want to look at. And here the 3 index that we wanted to include in our decision was the environment, economic, and social indices. So using these techniques, like, and they call it AHP, entropy, each of them give weight to importance of scenario or to the index that we are looking at. And then using the decision-making model, a technique of 2 techniques we have used there to make sure like the results that we are for ranking are compatible. And then we saw that like the type of results that we got, like for ranking scenario to select the best management practice was fertilizer location change, which was the pasture management. The scenario number 7 was the best scenario, and then fertilizer rate decrease, followed by irrigation rate decrease and irrigation plan change. In order to run this management system model, we have developed a survey, and we distributed the survey to ranch managers here, over there, and to more farmers, just to see what are to be able to get interpretation for the social index, which is the very for the economic index, for example, we had data for it. We had the nitrogen amount. We had the crop yield. We have everything to calculate it. For environment, we had looked at the nitrogen, and there are some equations to calculate the index of environment. But for social, we use the farmers' ideas and interpreted them Okay. So here, I would like to thank you all for attending today online and in person. Again, I would like to thank my team. Um, and thank you very much. And I would be very glad to take any questions if you have. The best scenario based on so the best scenario based on this multi-criteria, sorry, I'm going to repeat the question. The question was, what was the best scenario? Was it the 100% reduction or not? The answer is no, that was not the best scenario based on the precision making model. But if you like, I want to explain it here a little bit. Like if you look at the graph, yes, if we remove it, obviously we do not have nitrate in the system anymore. By looking at the graph and comparing visually, yes, this is the best scenario. But what are the impacts of it? Then the crop yield, you're gonna reduce it. Or like we are gonna have like socially, like there is no social acceptability for that. The farmers, they don't like it, the ranchers. Or like other things, like the only thing is very high there is the environmental index. So what this management models, they do, they consider all of them together to see which scenario is the best. So location change. The three pastures which was okay. The question again is like some explanation about like fertilizer location change. That's what you want, right? Scenario. Yes, this scenario was about like we had certain number of pastures fertilized, and then we ran the model based on the existing condition. We defined the amount of fertilizer in each pasture. We calculated that. And then we decided to like remove the ones with like highest level of nitrate to see how it impacts the amount of nitrogen in the groundwater. So here, if you look at this picture, all these hashed pastures, including the dark red ones, they are all under fertilization now. No, it, it's different rates. He is asking about like if the rates of fertilizer in all the pastures are the same, and the answer is no. It's like based on we got the database from the ranch crew, like the same as here, and then we had the amount of fertilization based on the different ranch in each pasture calculated and entered into the model. But after all, these three pastures not necessarily are the ones having the higher rates, but they produces highest amount of nitrogen in the groundwater. That's a good question. We have looked at the amount of fertilizer that has been implemented there. They are not the ones that with highest amount of fertilizer. So that's something like, that's a very good question. And we have to look at the reason why those are, uh, highly transfer the nitrogen into the groundwater. Yes, that's something, and it's different location to location. It's always different. All of these scenarios, as I mentioned, we have like based on the discussion with the team at Lock Island Ranch and based on their experience and how they prefer like which pasture they wanted to, if they agreed to, I mean, removing the pasture with the highest amount of fertilization. Any other question? Yes. The question is how many years of data we have used for modeling. That was it, right? And the second part was how the previous fertilization or management impact the model. Yes, longer the better, actually. That was that's the answer. And here we had like a good amount of data in terms of database management. We had something from 2009 to 2021. But we did not use all of them uh, actually get the final result, because we had to use certain amount of data for calibration, certain amount for validation, and because this model is kind of numerical model, is required like the transient model to be run separately, a steady model to run separately. At the end, we had like around 4 years of pasture management, like the fertilization management, and with all considering all best management practices to be implemented to our model. Any other question in the room? So I'm gonna check if someone has question. Does the modeling account for any legacy nutrients? This is a problem in our soil. David, it's from David Royal. David, like, no. But the thing is, like, for like the next stage for this study is to gather the data for phosphorus and looking doing the kind of like different scenarios, or maybe some similar scenarios, to see the impact of phosphorus, impact of management practices on phosphorus, and especially, yes, in that area, phosphorus is very important parameter to look at. But the answer is in this talk, in this study, we have not looked at phosphorus. We have looked at only nitrogen, but that's kind of future work for us. By the way, thanks for your question. That was the only online question I got. And if there is no more question, I can, we want to, yeah. Oh,
Okay, so we have just a couple of announcements before you go. We invite you to come back in January for our next ONA highlight on January 14th at 11 o'clock with guest presenter, Dr. Brett Baltimore. And he is the Extension Assistant Professor and Director of the UF Pesticide Information Office. He's going to be presenting what's a PULA and is a BLT more than a sandwich. So as always, I will share that registration info with you whenever I send the recording of today's event. We also invite you to attend the 2025 Florida Cattlemen's Institute and Allied Trade Show that will once again be held at the Okeechobee Agri Civic Center on January 23rd. Full day program, $5 to attend, and that $5 includes lunch. And if you don't already have it on your calendar, please hold April 17th for our next field day. That will be a full day event with morning presentations, a good lunch, and afternoon field tour. And registration for that event will open February 1st. If you're not already doing so, we invite you to follow us on social media. And if you do not receive our Friday email, newsy information stuff, please send us an email and we will be happy to add you. So again, thank you so much for joining us today, and I hope to see you back in January.